APRV, Advanced Biphasic Ventilatory Modes and the Clinical Management Protocol. Ventilator modes. You have three types. You have traditional mode, you have biphasic mode, you have advanced mode. In traditional mode, what here concept? The concept here is that inspiratory valve open and deliver the air to alveoli. During exhalation, expiratory valve close and an expiratory valve open to release the air. In this traditional, you have volume control, you have pressure control, you have SIMV, you have pressure support, and we are discussed that before. In the biphasic mode, the both valve, inspiratory and expiratory valve open. In this time, you can use BiPAP. In this time, you can use high pressure and the beep and respiratory rate. APRV release vent. In this time, you can use high pressure and low pressure. Unrestricted spontaneous breathing at all level. In this time, the patient can take a breath during inspiration and expiration. And advanced mode, pressure regulated volume control, proportional assist, volume support. Traditional mode, valve dynamics. Valve state restriction. In traditional mode, when the inspiratory valve open, the expiratory valve close completely. A clinical limitation, the patient cannot cough or breathe spontaneously during inspiration because the expiratory valve is locked. Strategy here, you can keep time inspiratory less than 1.2 to avoid fighting with mechanical ventilation. In the BiPAP and CPAP, when the BiPAP only applied, the expiratory valve remain unsealed at the baseline pressure. Free respiration. The patient breathes without added circuit resistance because the expiratory valve is not completely closed. BiPAP fundamental and the pressure curve. Definition here, BiPAP alternate between two levels, B high, pressure high, and B low, pressure low at a set time interval. With what you are seeing in the curve, B low and B high. What this oscillation? This oscillation you can take effort, cough, and breathing during this above pressure, B high pressure or low pressure. The patient can breathe freely either pressure level due to actively controlled expiratory valve and respond to dynamic to the patient effort. We're using our TLC trigger. Trigger here transition between the pressure B low and B high is initiated by the ventilator's interval clock. And the limit here, pressure limit, the peak pressure is held at the set target B high or pressure high. The ventilator maintain this pressure ceiling throughout the phase. Cycle here, time cycle. Termination of the inspiratory phase is governed by time, B low. Switch it back down to T high. This difference between pressure control and the BiPAP. Pressure control has plateau curve and active spontaneous oscillation they were found in the BiPAP. Clinical expiratory valve locked here during an inspiration. Spontaneous breathing allowed during inspiration. Clinical takeaway, because the spontaneous breathing is permitted during the inspiration BiPAP, it safely extend inspiratory time from 2 to 3 seconds without causing ventilatory dysynchrony. Mean airway pressure, we discussed before how we can increase mean airway pressure. Mean air pressure is between the average pressure applied throughout the entire inspiratory cycle presented by the area under the curve. The golden rule to improve the oxygenation, and increasing the airway directly improves the oxygenation. You increase first inspiratory time, you can increase inspiratory pressure, you can increase the beep to increase the main airway pressure. Parameter set in pressure control versus BiPAP. Inspiratory pressure, here pressure control 15, here pressure high 15. Time setting, time 1 second, time 2 seconds, we can extend more than 2 seconds. Respiratory rate here 20, respiratory rate here 12. The baseline pressure B5, the baseline pressure B low B5. In inspiratory expiratory ratio target 1 to 2 to 1 to 3. Here 1 to 1 or 1 to 1.1, we can use inverse ratio. Later on in APRV mode overview. The core concept, APRV initially BiPAP configured with an inverted IE ratio. T high prolonged paired to the ultra short T low. What you see here, T low and short T high, here, and T low is a short to start high pressure again, and T high. If you need high CPAP phase, T high, maintain recruitment and oxygenation. And the release phase, this T low, rapid drop to clear the CO2 without alveolar collapse. BiPAP versus APRV. In the BiPAP, you can set B high, you can set B low, but here beep. You can set T high, but here respiratory time. It is different in the APRV. You can set B high and B low usually equals 0. T high from 3 to 8 seconds. It's prolonged. And T low 0.3, 0.8 second. In APRV, respiratory rate is not directly set. It is derived. How to your parameters? Your parameters here be high from 25 until 30 centimeter water. B low equals 0. T high from 3 to 8 second. T low 0.3, 0.8 second. Here, so that tidal volume equal B high minus B low. If increase the B high, increase the tidal volume. Respiratory rate here 60 over the total about T high and total time of T high plus T low. In this time you can calculate the respiratory rate. Critical goal to prevent total lung emptying. T low if too long, if release time excessive, expired gas volume drop completely to zero baseline. Lung D recruitment and atelectotrauma. Adequate T low, release is stopped abruptly while the air is still flowing out of the lung. This create auto beep to stabilize the alveoli. Time constant, we discussed before about time constant, is important. Exhalation time constant, first time 63, deflating the lung, and second time 87% deflate lung, and third time constant 95% deflate the lung volume and reach to 95%. And now set of the time low. Time constant rules. Set time low to not exceed one time constant. Okay. To prevent emptying more than 63% of the volume. And method 2, peak expiratory flow. Set T low, so release the end when the flow reaches 75% of peak expiratory flow rate. Termination at 70% of peak expiratory flow. Gold standard method to precise the auto beep generation. I think here easy to set time low by equal one first time constant, and here you can by this diagram this pressure high 25, and when you write pressure low, and this flow curve peak expiratory flow when reach to 70%, 75%, the cycle to return back to B high and T high. For hypoxemia, low BO2, increase the mean airway pressure, increase the T high, and increase the B high, positive 2, and reduce the T low. For hypercarbia, increase the minute ventilation and cycling, reduce T high from 0.2 to 0.5 to increase the rate, and increase B high, positive 2, increase the delta pressure and tidal volume. Gradual transition protocol performed every 4 to 8 hours. Drop and stretch. Drop, reduce the B high by 2 centimeter water increments, and stretch, increase the T high by 1 to 2 second increments. What time the patient become ready to switch to CPAP? T high 12 to 15 seconds, near to continuous pressure, near your CPAP, and B high to 5 to 20 centimeter water, low support baseline. Thank you for attention.